Welcome to the channel Knowledge Star, Continuous Knowledge Excellence. My name is Nisha Masroor. In this video, we will get to know about detection of dopamine by cyclodextrin AUNPS. Now, our expert Professor Himadri B. Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Terry Dicon Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobio interface science, soft matter science, polymer physics and biophysics. We'll explain you in detail about this topic. So, to get complete information, watch full video without skip.
Sensing a neurotransmitter, dopamine. Now, is it possible to use this platform to detect this type of molecules? And dopamine, is a very important neurotransmitter and it controls signal transmission in the central and peripheral nervous system. And the disorders in this communication can give rise to serious pathological conditions, serious diseases like Parkinson's and Alzheimer's disease, because they are all neuro diseases. And this dopamine plays a very, very important role in the neurotransmission pathway. Okay, in this, again, we are going to use the gold nanoparticle. The partner with gold nanoparticle is a carbohydrate molecule called the beta-cyclodextrin. Beta-cyclodextrin is a cyclic aromatic type of carbohydrate. You see the chemical structure here, alpha, beta, and gamma. They are identical except that the rings are bigger. When you go from alpha to gamma, the ring becomes much larger. There are more units of carbohydrates in it, so it becomes larger. Otherwise, the material is the same material. Okay, again, we make first the gold nanoparticle. So you use the same gold precursor, mix the beta-cyclodextrin solution to it at a certain concentration. And then again, you need to take the pH to the basic pH. And after a while, you will see that reaction has completed and you have gotten gold nanoparticle. Sometimes it may be necessary for you to add sodium borohydride if you want a better reduction. Say beta-cyclodextrin also acts as a reducing agent on this precursor salt, orochloric acid, HAUCl4. But to enhance it, many times an additional reducing agent is used, which is NaBH4 here, sodium borohydride. So there is no harm in sodium borohydride. You can get a better yield of the gold nanoparticles, so it can be used. But the method will work even without the using of NaBH4, but the yield will be less. So this will give rise to produce the gold nanoparticles, and our standard deep wine color dispersion will appear from a transparent precursor solution over a period of time, and you are sure that your material is now converted to nanotized gold. Now, in order to do the testing, you take a dopamine solution and you add with this beta-cyclodextrin AU gold nanoparticle dispersion. Shake it, mix it for a while, and then subject it to UV visible spectroscopy. This assay is as simple as this one. Now you see the UV visible spectra of this one, and with the concentration of the analyte, which is dopamine in our case, the color of the dispersion you see is changing like this. Higher concentration, there is loss of color, and finally it becomes greenish and finally becomes very, very dim. And what happens is the beta-cyclohextrin gold nanoparticles, this mixture that we have made, this provokes a networking or the formation of the gold nanoparticles into a network which is induced by dopamine. So more dopamine you have, more extensive is the nanochain network of gold. This is what it gets formed inside the material.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
If you want to go deeper into the science of it. And because of this, the color change occurs here. Quantitatively, the visual spectra will change like this one. Again, you have one prominent peak at 525, 530, and another weak peak at 700 or so here, like before. Say the gold nanoparticle network that I've been talking about. Higher the concentration, more prominent is the network. This is 2 micromolar, 2.25 micromolar, 3.6 micromolar concentration of dopamine. This is twice that, about 7.5 micromolar. And you can see this nice network of these. They are all gold nanoparticles joined together, with the dopamine acting as the bridging agent there. And that gives rise to change in the color of the test solution. Again, as before, we do absorbance at a high wavelength to absorbance at lowest wavelength, 650 to 520. And you see, as you increase the concentration of dopamine from 0 nanomolar to about 750 nanomolar, the sensitivity is increased drastically here. At 0, this was as nothing. 40 nanomolar is slightly increased in the sensitivity, and then 100 nanomolar, but higher concentration is prominent. If you just want to look at the 520 nanometer absorption band and see how the concentration of dopamine affects it, then this is the answer to that. Absorbance measured at 520 nanometer, and you see the absorbance value increasing with the increasing concentration of the analyte. So this again, a linear relationship can be established between these two things, which will solve the purpose of the calibration. Corresponding color change, I have already mentioned you in the previous slides. The color will change of the dispersion, giving you the first-hand information about the formation of the complex and establishing the presence of dopamine in the solution. This is the same plot that has been replotted here, and you see that initially up to 400 nanomolar, this linear relationship is there. So low band detection is excellent. But even at higher, there is wonderful linearity, but there is a discontinuity here. There is change in slope. So that doesn't create any severe problem as far as the measurement is concerned, because there are two linear, well-defined regimes here. Okay, now look at the specificity of this measurement. Will the other interfering molecules hamper the detection of dopamine assay? This is the answer to the question. The same ratio, absorbance at 650 nanometer divided by absorbance at 520 nanometer, has been plotted here for different interfering molecules: hydrogen peroxide, glucose, lactic acid, ascorbic acid, urea, etc., and other neurotransmitters here. They're all named here at the bottom. And you can see that for dopamine, this response is actually fantastic. So the takeaway from all these studies is you have a fixed platform. If you want to do a colorimetric detection, gold nanoparticle is the best. Only thing you need to decide is what to put on its surface. That's where certain amount of decision taking is required and some amount of information gathering is required. If you have chosen the right ligand on its surface, then with a lot of specificity, you are going to be able to detect a specific analyte.
I hope you like this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organize the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC, in which you can also be a part of, like mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. Subscribe to the channel Knowledge Star and hit the bell icon to never miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.